History of physical geography. Most individuals define geography as a field of study that deals with maps, which is only partially correct. A better definition of geography may be the study of natural and human constructed phenomena relative to a spatial dimension. Under this definition, geography is often divided into two major branches: physical geography and human geography. Physical geography is a scientific discipline that addresses the distribution of natural features and processes within a spatial or geographical reference frame. Its history is often intertwined with developments in human geography, which involves all phases of human social life in relation to the physical Earth. The history of physical geography spans nearly 4,000 years. The main purpose of early investigations was to map features and places observed as explorers traveled to new lands. At this time, Chinese, Egyptian, and Phoenician civilizations were beginning to explore the places and spaces within and outside their homelands. The earliest evidence of such explorations comes from the archaeological discovery of a Babylonian clay tablet map that dates back to 2300 BC. The early Greeks were the first civilizations to practice a form of geography that was more than a mere map-making or cartography. Greek philosophers and scientists were interested in learning about the spatial nature of humans and physical features found on the earth, as is manifested by Herodotus's volumes that describe the human and physical geography of the various regions of the Persian Empire. They were also interested in the form, size, and geometry of the earth. Aristotle, about 384 to 322 BC, hypothesized and scientifically demonstrated that the earth had a spherical shape. Evidence for this idea came from observations of lunar eclipses which occur when the earth casts its circular shadow onto the moon's surface. Besides, Eratosthenes, about 276 to 194 BC, accurately calculated the circumference of the earth using a geometric proof. Ptolemy, during the 2nd century AD, developed a number of map projection schemes as well as the coordinate system using latitude and longitude. Most of these early Greek and Roman geographical insights, however, were forgotten during the Middle Ages. For the most part, from the 5th to 13th centuries AD in Europe, the Vikings of Scandinavia were the only group of people carrying out active exploration of new lands. The idea of a spherical Earth did not resurface until the Renaissance, when European navigators, including Christopher Columbus, Ferdinand Magellan, and Sir Francis Drake, explored the oceans and the Americas. In 1492, Martin Behaim created a spherical globe depicting the Earth in its true three-dimensional form, which was a significant advance over two-dimensional maps because it created a more realistic depiction of the Earth's shape and surface configuration. European colonization and exploration of the American frontier that took place from the late 1700s to the early 1900s not only resulted in increasingly detailed physical geographic studies, but also had a great effect on the further development of physical geography. The European search of raw materials required by industries during the Industrial Revolution fostered the creation of geography departments in the universities of the colonial powers and the birth and development of natural geographical societies, thus giving rise to the process identified by Horatio Capell as the institutionalization of geography. The other important influence during 1900s is the evolution theory of Darwin, which suggested that natural selection determined which individuals would pass on their genetic traits to future generations. As a result of this theory, evolutionary explanations for a variety of natural phenomena were postulated by scientists, which meant an important impetus in the development of biogeography, an important branch of physical science. Physical geography underwent a quantitative revolution beginning in the 1950s, when geographic investigations became more scientifically rigorous. Since then, the central focus of research in physical geography became measurement, with which also came mapping, models, statistics, mathematics, and hypothesis testing. The quantitative revolution was also associated with a change in the way in which physical geographers studied the Earth and its phenomena. Researchers now began investigating the process rather than the mere description of the environment. The revolution continues today with ever-improving geographical methods and tools, like satellite-aided navigation using the Global Positioning System (GPS) and images of the Earth collected from space.